I would like to talk about the subject of the invention called jet pump for self-relief of gases petroleum wells. First, the abstract. The invention is based on the use of a jet pump that is mounted on a production pipeline. It works to withdraw the separated gases through the annular vacuum in non-flowing oil wells, which operate by artificial lift, using submersible electric pumps. Technical field oil wells are divided into two types. Flowing wells. The pressure of petroleum-borne layer is sufficient for its smooth flow up to the well surface towards a collection station. Number 2. Non-flowing wells. The pressure of petroleum-borne layer is insufficient for its flow up to the well surface towards a collection station. In this case it depends on artificial lift. Using centrifugal electric submersible pumps is the most conventional method worldwide applied. This method depends on the fact that separation and relief of petroleum-associated gases is a must using manual techniques. Otherwise, such gases are to be gathered and burned off. Technical background. As the figure shown, petroleum is produced from non-flowing wells via artificial lift system, the most important of which is centrifugal electric submersible pumps. Oil well production is controlled using a set of wellhead valves, called wellhead assembly, charismacy. For a pump of high efficiency, separation of oil-associated gases is a must, before reaching a downhole pump suction opening. This is achieved by installing mechanical gas separator onto the pump having its own motion from the same pump shaft. Mechanical gas separator acts on separating petroleum-associated gases upstream of a pump inlet to be ejected into the annulus between production pipeline strings, pump discharge, and well wall. These gases are removed by a connection of annulus passage through a wellhead assembly, charismacy, with pump discharging path via a check valve and regulating valve. Thereby, gas and petroleum, oil, streams are driven into a collecting station averting the way to the pump. As such, gases are discharged from an annulus, number 3 as the figure shown, to a production line, number 1 as the figure shown, offsetting the annulus gas pressure against product line pressure of surface discharging pump. However, such pressure is not sufficient for all downhole separated gases be disposed of merely by using mechanic separator. This causes gases infiltration into the pump suction, causing the pump malfunctioning, damage of its parts, shortage of production and ultimately leading to its breakdown. In such event, the annulus suspending gases must be cleared off and pressure lowered by opening an open air passage to the annulus, number 3 as the figure shown, via wellhead assembly. Thereby, the annulus pressure becomes as low as possible or a little higher atmospheric pressure. Then, the well is re-operated. This is called well gases relief into open air. Such process is of hazardous consequences. Pollution of surrounding environment. Problems to be solved. A well gas relief for maintaining the annular space and downhole pressure almost near atmospheric pressure, results in higher production of the well. A progressive increase of annular space pressure, out from gases separation, has a negative impact on pump performance, thus gradual decrease of well productivity till its halt, depending on pressure, amounts of separated gases displacing oil surface and entering into pump suction. Thus, well productivity shall be fluctuating. Its ongoing operation is based on good follow-up regular gas relief and clearance, in other words depends on manpower who would be prone to all concomitant risks surround environment pollution, loss of gas amounts. Summary of invention. The new invention relates to a well self-relief with no man intervention or underlying danger, for example environment pollution, whereby, gas amounts can be maintained and pumped with oil to a pooling station, which is the desired aim. This can be achieved by applying the jet pump theory, as the figure shown. Summary of invention. Having all required tests and investigation done on a well at question, a proper production hole is delimited to be used as a surface nozzle, no. 2 as the figure shown. Onto production line, pumping discharging. Number 1 as the figure shown. It is arranged for accelerating oil flow generated lowering pressure in a downstream nozzle area. Number 3 as the figure shown, and thus being under a vacuum. A gas relief passage, number 6 as the figure shown, is to be extended from its annular space, number 5 as the figure shown. By providing both a check valve, number 7 as the figure shown, and regulating valve, gases are withdrawn from the annulus, number 5 as the figure shown. To be well mixed with oil in the production line, the aforesaid well mixing guarantees the smooth flow of oil heading to the production plant and as much as possible a lower pressure of the annulus. Accordingly, the annulus gases are to be relieved with no man intervention while adjusting ideal conditions and pressure level for well-operated pump and non-stop unfluctuating production process. Benefits of well gases: self-relief, no intervention of manufacturer. Continuous production with no need for stopping the pump because of gases. Maintenance of pump parts in a good condition. Not causing environment pollution. No loss of gas amount. Well mixing of gas with oil in the production line and smooth flow thereof. Environmental compatibility for the operation of oil wells. Description of jet pump. A nozzle, production hole of the well, converting pressure into kinetic energy, generating lower pressure and a vacuum area. Mixing pipe is a part of pipe having a diameter proportional to that of production hole and proper length for allowing well mixing of gases with oil. Connection configured to convert kinetic energy into pressure. Applicability. Well gas relief and withdrawal of separated gases upon using artificial lift using centrifugal electric submersible pumps. This is so important for pump maintenance in good condition having higher efficiency and ongoing operation. The well production hole is to be used for converting pressure exerted thereon into a velocity, kinetic energy, thus generating a vacuum. Based on the production hole diameter, the rest parts of jet pumps are designed in terms of diameter, mixing pipe length, speed lowering connection, converting kinetic energy into pressure. All required parts and items are domestically manufactured.